Suhi,
and William. For this experiment, we'll be using fruits to conduct electricity.
and now we're gonna see James, Justin, and Jason.
Yes, it's true that we can conduct electricity using a fruit. But what many people don't understand about the fruit electricity experiment is that the electricity isn't really in the fruit itself. In order to fully comprehend the inner workings of how a fruit like lemon or orange can conduct electricity, it's important to understand how a battery actually works. A battery, also known as an electrochemical cell, requires 3 parts in order to function: 2 electrodes and 1 electrolyte. Simply put, electrodes are the plus and minus signs of a battery through which electricity flows, and an electrolyte is a substance that contains free ions or atoms with electric charge that enables the substance to conduct electricity. In this experiment, the zinc metal strip will function as the negative electrode, also known as the anode, and the copper metal strip will function as the positive electrode, also known as the cathode. Because the copper metal strip has a stronger desire for electrons than the zinc metal strip, it will literally steal electrons away from the zinc. However, electrons can't just flow from the copper to the zinc directly. They need a pathway. This is where our electrolyte comes into play. For this experiment, our electrolytes will be the lemon and the orange. Because both fruits contain large amounts of acidic juice filled with ions, they are ideal candidates for electrolytes. With all 3 requirements for a battery fulfilled, now we can use the lemon or the orange as a mini battery.
An Italian physicist by the name of Alessandro Volta invented the first electrochemical battery in the 1800s. This primitive battery, consisting of 1 zinc metal strip, 1 copper metal strip, and a cup of salt water brin, was able to conduct electricity without any other external power source. For our lab project, our group decided to utilize Volta's ingenious theory and make our own naturally powered mini battery. Our experiment is essentially just a slight variation of Volta's original experiment. Like Volta's experiment, we will be using zinc and copper as our electrodes. But instead of using saltwater brin as the electrolyte, our group decided to use something much more familiar: fruits. A knife is used to create 2 deep lines in each of the 4 lemons. A copper metal strip and a zinc metal strip is inserted into the 2 lines of the 4 lemons. Alligator clips are used to connect the lemons to the LED.
It is important to make sure that alligator clips are clipped copper to zinc and zinc to copper. It is also important to make sure that zinc is connected to the positive end of the LED and copper is connected to the negative end of the LED.
Before we measure the current and the voltage, let's see if the LED works. See, the LED lights up. After the circuit is set up and the LED lights up, the multimeter is used to measure the voltage for each component. Then the multimeter is used to measure the current across the circuit, 0.1 milliampere. This is a voltage and current graph for the lemon circuit. As you can see, the current is constant throughout the way because this is a series circuit. Previous steps are repeated using 4 oranges instead of 4 lemons. This is a voltage and current graph for the orange circuit. It is very similar to the graph shown before because this is a series circuit as well.
How was the experiment overall, Suhi?
The experiment went very well. We were able to light both of our light bulbs by using 4 oranges and lemons for each of our circuits. Before we measured our currents and voltages, we expected the current measurement to be similar since it is a series circuit. But in our experiment, we used 4 iron metal pieces and 3 copper pieces with a 1 copper coin. Our current measurement came out different. If we had used all of the same materials, replacing the copper coin with a copper metal piece, we would have a similar current measurements.
Just a feeling, thinking 그대로 말해. Think about it.
Batteries made out of citrus fruits are not the only naturally powered batteries in this world. For instance, vegetables such as potatoes contain enough acid to light up small LED. However, the reason why we chose lemons instead of potatoes was that lemons are a much more efficient electrolyte. While we only needed 4 lemons to light up the LED, we would have needed 8 potatoes to achieve the same feat. Therefore, fruit electricity experiment was a much more efficient method compared to vegetable experiment. So, Justin, James, Jason, and John, do you guys get it now?
눈이 부시게 하늘이 맑아 서늘한 바람 불어 기분이 좋아